m for r, and here we have s, so this is why the maximum is m times s. Okay, so the value will be between 0 and m dot n, or m times n. Okay, so there is no constant on attribute constraint on attribute b. So values of b may be no match all. We can find here a row doesn't match with any of these, second row doesn't match, third row doesn't match, the last row doesn't match, so 0. Or every line will match with all rows of S. So m times, so the result will be in between 0 and this result. Okay, so no match at all 0 row, and match fully all b values equal m times n. So every row in R match with all rows of S. Okay, this is the result is between 0 and m times n. The fourth, okay, this is a new question. Consider R contains A and B with m rows R and SAB the same, huh? They have the same relational schema, AB, AB, with n rows. So for example, how many rows the union of R and S can contain? This is nice. If S and B is a subset, or if R and S is a subset, let's assume, because n, which is for S, is greater than n, let's assume R is subset, right? R union S. So union contains, remember, union contains all distinct rows. We don't add duplicates or doubles, okay, from both. So the minimum number, what's the minimum number? And you should always think about minimum number and maximum number. The minimum number is what? Is that you assume S is a subset of R is a subset of S, because R has less number of rows, which is m, right? R m less than n. So it's probably that R is the subset of S, because S number of rows of R is less than the number of rows of n. So this could be a subset of this. If in this case this is subset of this, it means that what? It means that the R union S is equal to S, because R is already subset of S. So the result, the minimum is n. The maximum number is that R and S, they are not subset to each other, and in this case they don't have any row in intersection. It means that all the rows of R are not a part of S. So it means that if we do union, you will add the rows of R to rows of S. So this is why you should add m plus n, because no tuples in common. Okay. For example, here, as you see here, if we add this and this, it will be these 6 with 4, 10. As you see, we don't have any row in common. This row is totally different than this row, as you see, okay? So if we don't have rows in common, you will add all this to do all this if you do union. For sure, here they should be the same BID title author editor, and here it should be the same, B title author editor. But as you see, we don't have any common row in between. So M plus N. Okay. The answer is between N, the minimum, and the maximum. Okay. The second exercise in part B, how many rows the intersection of R and S can contain? R and S intersection. The minimum is that they don't have any intersection. So number of rows is 0 or tuples. But what's about the maximum? The maximum is that R is a subset of S, or all rows of R in S, because the number of rows of R is less than the number of rows of S. So the intersection should be these numbers of R that exist in S, which is M. So the number of tuples or tuples of R in S is M. So the result is M. So the intersection is between 0 and M. Here it means that if all rows of S are in S, they exist in S. And if they exist in S, it means that these rows are the form or represent the intersection part. So they represent M. The third exercise, how many rows the minus of R and S can contain? Remember, R minus S, it means that tuples of R that doesn't exist in S or that are not in S. So these rows represent rows in R, but not in S. They don't have they don't exist in S. How we can calculate? What's the minimum of these? So we should find the minimum and the maximum. Okay, let's calculate the minimum number of these rows if these rows tuples in R that are not in S. The minimum if R is totally in S. If R is totally in S, what does this mean? Remember, we are calculating rows in R and not in S. Now we suppose R, all rows of R in S. So the minimum is 0. Because why 0? Because all rows of R in S, and we are looking for all rows of R not in S. So in this case, the number is 0. 0 because all rows of R in S, and we are looking for all rows of S not in S. So the minimum is 0. What's about the maximum? The maximum is that none of rows of R, there is in R, all rows of S not in S, which is M. So the maximum match is M. Why M? As I told you, we are looking for all rows in R, but not in S. So if none of rows of R in S, this part of what we are concerning about, which is M, because all are not in S, and the number of rows of R is M. So all rows, which is M, not in S. So this is the maximum, so M. So the answer is between 0 and M. Okay? The fourth exercise. How many rows the minus of S and R can contain? Now the reverse of S and R. Now we are looking for S and S minus R. What does this mean? S minus R, it means that we are looking for all tuples that exist in S but not in R. And remember, number of tuples in S is M and N, and in S is N, but N greater than M, right? So number of S that are not in S, if we suppose all number, the first case, we suppose all numbers, all rows of R in S. This means that there is another part of S that's not in R, because S is greater than number of rows in S is greater than the number of rows of M. So because it's greater than, M is greater than, N is greater than M. So if R or rows of R in S, so the number of rows that are not in S, that are in S and not in R, is N minus M. So the minimum is N minus M. N minus M. This is the minimum. So it's the part of N that's greater than S, which N minus M. Okay? This case, it means that all tuples of R, which is M, in S. So the part N minus M is for sure it's not in R. Okay? And the worst case, assume that all tuples of S, it means that R and S, they don't share any tuple in common. What does this mean? It means that if R and S don't share, it means that none of tuples of S are in R. So if all tuples of S, which is N, not in R, so the number of tuples that we are looking, which is in R, is all tuples of S. All tuples of S are not in R, and all tuples of S is N. So this is the maximum number, which is N. So we are in between N minus M and N. Okay? Okay. Now we want to move to exercise 4, and which is very, very important, and it's like exam exercises, all of them for exams. Okay, exercise 4, this is very important. Consider the following database: book ID contains book ID as primary key, title, author, title book,